Imagine, waking up one morning and your digital world is just locked, solid.
Yeah.
Your smart home stuff is frozen. The app for your morning coffee, it's just spinning.
Mm.
And suddenly the internet hasn't just paused. It feels like it's, collapsing around you.
That's exactly the feeling so many people had recently. And what's really striking, I think, about this specific disruption is that, it wasn't hackers, it wasn't some big geopolitical thing.
Right.
Our sources are really clear this was internal, just a complex, sort of a messy chain reaction deep inside Amazon Web Services, AWS.
That's right. So for this deep dive, we're really digging into the source material on that massive AWS outage. It was centered on their U.S. East 1 region, that's Northern Virginia, across October 19th and 20th.
A critical hub.
Absolutely. And our mission here is to understand first just the huge scale of it all, then trace the technical dominoes that fell, one after another.
See how it actually happened.
Exactly. See the real-world impact. And then we also need to touch on that separate U2 outage that happened just a few days before, just to ask, how vulnerable are we right now with these huge centralized cloud providers?
Yeah, and maybe just to set the stage real quick, AWS, people call it the internet's invisible backbone, right? Think of it like the ultimate digital landlord, renting out server space, computing power to governments, universities. I mean, so much of the global economy relies on it.
And they're huge. What is it, like 30% of the whole cloud market?
Around that, yeah. So when a piece of that infrastructure stumbles, especially a core region like US East 1, the ripple effect is just immediate and, pretty massive for almost everyone online.
Okay, so let's unpack that scale then. Because the numbers, they're kind of mind-blowing. This wasn't just a little blip.
No.
AWS itself said it had to fix issues across 142 different services. And at the peak, over 9 hours, Dow Detector logged, over 6.5 million user reports. Sources say well over 1,000 companies were hit hard.
That sheer volume, it just shows you the dependency, doesn't it? And the key thing to grasp, I think, is that domino effect you mentioned.
Right.
Because so many apps are built on AWS, services that look totally separate to you, the user, they just went dark when that underlying structure, that scaffolding, disappeared.
Yeah, we saw chaos just spread instantly. I mean, Signal had issues. Snapchat saw spikes of over 10,000 reports. Reddit users were calling it one of their worst outages ever. 11,000 reports there.
Wow.
And then big games, Fortnite, Roblox.
Yeah.
Even streaming like Hulu, all scrambling at the same time.
And the irony, of course, is Amazon's own stuff was hit maybe the hardest.
Right.
Ring doorbells just show blank screens, failed to connect.
Yeah.
Alexa couldn't do basic things. You couldn't even download a Kindle book. It's like the mothership couldn't keep its own systems running.
And beyond the fun stuff, think about just daily logistics. The Starbucks app, right? Mobile ordering. Yeah. Completely down for loads of people.
Ruined mornings everywhere.
Totally. And banking, too. Big UK banks like Bank of Scotland, Halifax, Lloyds reported problems. Finance apps like Coinbase, Robinhood, Venmo. Right. People frozen out of transactions.
But the one that really jumped out at me from the sources was the hit to education.
Yeah, Canvas.
Canvas, the learning platform used by, maybe half of North American college students. It just became inaccessible.
Imagine being a student. Midterms maybe, deadline looming.
Exactly. Yeah. Ohio State, UC Riverside were mentioned. Needing to submit something, take a quiz, and you just get an error. It wasn't just inconvenient, it actually stopped online classes, K-12 through university. Just shows how systemic this was. It hit everything.
Okay, so let's get into the technical weeds then.
Yeah.
How did this massive cascade even start? The sources, they point to the AWS report, right? Pinpointing the first signs late on October 19th.
Yeah, late evening on the 19th into the early hours of the 20th, they started seeing increased error rates and latencies. That was the first whiff of trouble.
And the actual trigger, the first domino.
Yeah. They nailed that down to 12:26 a.m. Pacific time on the 20th. It was specifically DNS resolution issues for the regional DynamoDB service endpoints.
Okay, let's translate that a bit. DynamoDB, that's Amazon's huge database service, right?
That's
Handles
right.
Tons of traffic.
Core database, yeah.
Yeah.
NoSQL. Very important internally and for customers.
And DNS is the internet's phone book, basically.
That's the classic analogy, yeah. It translates the names we use, like a website address, into the numerical IP addresses machines need. So in this case, DynamoDB, the database, it was trying to call other internal AWS services, but the phone book was broken for its specific regional address. It couldn't look up the number for its own database endpoints, so the database itself started failing.
Okay, but why is that failure point so critical? I mean, it's one database service having a phone book issue. Shouldn't redundancy just kick in? Why did it spiral like that?
Well, this is the really crucial part, according to the sources, that DynamoDB failure didn't just affect the database itself. It caused a subsequent impairment in the internal systems of EC2.
EC2,
Yeah.
Elastic Compute Cloud, the virtual servers everyone rents.
Exactly. The absolute foundation for so many customers. And here's a link. Certain critical internal AWS tools, the ones that manage and deploy EC2 instances, they themselves rely on DynamoDB for configuration data, tracking capacity, state management, that kind of thing.
Okay.
So when DynamoDB's DNS lookup failed, those internal EC2 tools couldn't get their own information. It wasn't that the physical servers vanished,
Right.
but the management system essentially lost track. It thought the capacity was gone or it couldn't verify it.
And that explains the terrifying error message customers were seeing. Insufficient capacity error.
Yeah.
The machines were probably there, but the system managing the inventory, it was broken because its database lookup was broken.
Precisely. That capacity registration failure, that was the bottleneck. And as those EC2 management problems piled up, it crippled the next layer down, the network load balancer health checks.
Okay, so load balancers manage traffic flow.
Right. They check if servers are healthy before sending traffic. When those health checks started failing because of the EC2 instability, it caused network connectivity problems for just a huge range of other services that depend on them.
And that's where things like Lambda, CloudWatch, SQS got hit. Can you quickly remind us what those do?
Sure. Lambda is serverless computing run code without managing servers. SQS is a message queue service, helps different parts of applications talk to each other. And CloudWatch is for monitoring, keeping an eye on performance and health.
So basically, the core servers and networking got shaky, and all the essential management and messaging tools started choking.
That's the gist of it.
And the recovery, it wasn't just flicking a switch back on, was it?
No, not at all. It was complex. AWS had to apply fixes, but they also had to throttle things, basically slow down operations. They limited new EC2 server launches, slowed down how fast Lambda could pull messages from SQS just to stabilize the system under load.
Which is why it took so long. Full service wasn't back until late afternoon the next day.
Yeah, a slow, bumpy recovery, as experts put it. And they were very clear this wasn't an attack, just a, quote, good old-fashioned technology issue. A really bad one.
Okay. Now, the timing here is interesting because AWS wasn't the only tech giant having a really bad week, right?
No, exactly. Just days before, on October 16th, Google's YouTube had that huge global outage.
Right. Affecting YouTube itself, YouTube Music, YouTube TV. Something like 800,000 users reporting issues globally.
Yeah, people just saw playback error or something went wrong. Very frustrating. And, there was immediate speculation. Was it a DDoS attack? Something major.
But Google never really said, did they?
No, they got it resolved, but they stayed pretty vague on the specific technical cause for that blackout.
There was that one interesting detail, though, about the YouTube incident. While the videos weren't playing, apparently things like comments and recommendations were still loading for some people.
Yeah, that was noted. It's sometimes called graceful degradation. The idea that non-essential parts of a system might keep working even if the main function fails.
Which seems quite different from the AWS situation we just described, that total cascade.
A very different failure pattern, yeah. And given how close the dates were, YouTube on the 16th, AWS on the 19th and 20th, naturally, people started asking, hey, are these two massive outages connected somehow? Is this like the start of something bigger?
Well, our sources seem pretty clear on differentiating them.
They do. Two distinct events, two different major cloud providers, Google Cloud for YouTube, AWS for, AWS, different infrastructure, different underlying technical problems, whatever YouTube's was, and the specific DNS database issue for Amazon.
So no technical link found between the two specific incidents?
No direct technical link, no. But the coincidence, I think, it does highlight that broader vulnerability, doesn't it? It's a stark reminder that even these massive systems designed for resilience, they can fail spectacularly. No one's immune.
Which really brings us to the bigger picture question, doesn't it? What does this all tell us about how much we rely on these cloud giants?
Yeah, experts seem pretty unified on this. The quote that stuck out was, "The world now runs on the cloud. And when just one core region like US East 1 stumbles."
It hits huge parts of the global economy.
Yeah.
Because everything depends on just, 3 or 4 major companies?
Pretty much. And the business impact was just immediate and for many devastating. The word used was disaster for companies running critical operations entirely on AWS.
And the cost, I saw some estimates, was it something like $75 million an hour globally during the peak?
Yeah, that was one financial analysis, an astronomical figure. And get this, Amazon itself apparently accounted for about $72 million of that hourly loss internally, just shows the sheer concentration of economic activity running through that one region.
Wow, 75 million an hour.
I know.
That's staggering. Which then forces the question, okay, if your business lost millions because you couldn't operate for almost a day, what can you actually do? Do you just send AWS the bill?
Well, that's where let's say, the structure of the cloud business gets really challenging for customers.
So.
Legal experts point out that everyone using AWS operates under standard contracts, service level agreements, or SLAs.
Right, the uptime guarantees.
Exactly. They promise a certain level of uptime, but if they fail to meet it, like they clearly did here, the contract spells out the remedy.
And that remedy is?
Almost always defined as nominal service credits.
Meaning?
Meaning, basically, a discount on your next AWS bill, often calculated based on the downtime duration, but usually capped and, crucially, it typically does not cover your actual financial losses. Things like lost revenue, damage to your reputation, disruption to your supply chain. None of that is covered.
Wait, so a huge company losing millions, maybe hundreds of millions, in sales or operations, AWS just offers them a coupon for next month's cloud bill.
That's essentially it, yeah. The SLAs are written very carefully to limit AWS's liability. The risk of those consequential damages, that stays with the customer.
So the entire digital economy has kind of agreed to this deal. Massive efficiency and scale from the cloud, but you shoulder most of the financial risk when it breaks.
That's the fundamental trade-off, absolutely. You get power and flexibility you probably couldn't build yourself, but the provider controls the terms, and the recourse for failure is, well, limited.
It's efficient until it isn't.
Precisely.
So, okay, here's the final thought. Maybe, for you listening to chew on. Experts kept noting that AWS, like other major clouds, is built with massive redundancy. Multiple data centers, availability zones, all designed to stop exactly this kind of failure.
Right, that's the whole point of the architecture.
So if a failure is starting with something as basic as a DNS lookup for one database service, DynamoDB can still trigger a cascade that takes down 142 services in a critical region like US East 1, despite all that redundancy. What does that tell us? What new kind of architectural independence, maybe something beyond just having more physical zones, does the industry need to even think about to really protect this digital infrastructure we all depend on now? Because that deep interdependence, that seems to be the core vulnerability exposed here.